I welcome you all viewers, especially students, to this online classes organized by the State Council of Science, Technology and Environment. So today's class will be doing the chapter 11 from your maths book, that is constructions. So let us begin. So let us do the chapter 11, exercise 11A, question number 1. We have to divide a line segment 7 cm and divide it internally in the ratio 2:3. So first of all, let us draw first the line segment 7 cm. Just take your ruler and measure 7 cm. Okay. Just call this point A, this point B. This is the line segment AB of 7 cm. So now, next step what we will do is, we take any ray which makes acute angle with AB. Okay, I'll take this ray which makes acute angle with AB. Let's call this one X. So next step, what you do is, with your compass, okay, you take a small arc, okay, a small arc like this. You fix this arc, and then from point A, you cut at this ray AX. Same arc again, at this point of intersection, you cut again. One more. How many you have to cut? Since the ratio is 2:3, which is at these 5, so you just cut 5 points. Okay, I've done 2, so cut 3 more. 3, 4, then 5. Okay. Then call this one A1, this one A2, A3, A4, A5. Next step, what you will do is, you join B with A5. Okay, join them. Okay. Now, you have to cut 2:3, right? So, from A2, you join with a point in AB, with the line segment AB, but then this line should be exactly parallel with BA5. Okay, to make it parallel, what you will do is, the same arc, okay, this same arc length that I have cut these points, this same one you cut from B. Okay, cut it. Okay. Okay, leave like that. Okay. So, you see, from A2, you join with, suppose this one is your A1, this one is your A2. You join both these 2 points. Okay, join them. You call this one C. These lines CA2 and BA5, they are exactly parallel. Okay, if you want to confirm, you take your protractor and you measure the angles. Okay, how much is this angle? From this side you will get 40. This one exactly 40. Okay, so that means these 2 lines are exactly parallel. So therefore, you have got this AB, okay, which is divided in the ratio 2:3. So you just write here, AC is to CB is divided in the ratio 2:3. So this is the required construction. Okay, let's do the next question from exercise 11B. We have to construct an isosceles triangle with base 8 cm and altitude 4 cm. Also, we have to construct another triangle whose sides are 2/3 times the corresponding sides of this first isosceles triangle. So first of all, what is an isosceles triangle? An isosceles triangle is a triangle where 2 of its sides are equal. Okay, so first of all, what we will do is, we'll first draw the base 8 centimeter. So take your ruler, okay, draw exactly 8 centimeter. Okay, call this point A, this point B. Next, see, we have to draw an altitude of 4 centimeter. We all know that altitude is always perpendicular to the base. So what we will do is, we will draw the perpendicular bisector of AB. So with your compass, okay, you take a much bigger arc from point A, okay, you cut above and below. Same arc from point B, you cut above and below. Okay, so join these two lines. You see these lines, this point of intersection with this point of intersection, you join them. You will get the perpendicular bisector of AB. Okay. Okay. So now the altitude is 4 centimeter. Draw 4 centimeter on the rough side. Okay. Draw 4 centimeter on the rough side. So with your compass, you measure this 4 centimeter. Okay, measure it 4 centimeter, and then from this midpoint you cut here on this perpendicular line. So this is your altitude. Call it C. Call it C. So now you join AC and BC. Join AC and BC. Okay, so therefore this is the required isosceles triangle with base 8 centimeter and altitude 4 centimeter. Okay, next we have to construct this other triangle whose sides are 2/3 of this first triangle. So what you will do is, you take any ray, okay, from point A which makes an acute angle with AB. So just draw a ray from point A. Just call this one ray AX. Okay. Now, since we have to draw the triangle which is 2/3 of this, so you locate 3 points. Again, you take any arc, much smaller arc, you divide or you locate 3 points. First, 1, again from this point, 2, again from here, 3. So 3 points. Now you give names. Just take this one A1, this one A2, this A3. Now join B, A3. Join them. Exactly, okay. So now what you will do is, you have to do 2/3, right? So from A2, you join with a point on the line AB. But that line should be exactly parallel with BA3. So how do we get exact parallel? What you will do is, with the same arc length, from here to here, right? You take from B, then you cut this one. Okay? Just enough that one. So now, what you will do is, you join these two. Okay? You join these two. This A2, this line will be exactly parallel with BA3. So therefore join them. Okay. I'll make this dotted line. Okay. Just call this one B prime. Okay. From B prime, you have to draw a line which meets at a point CA. But this line here should be exactly parallel with this CB. So what you do is, the same arc length same arc length. I did not move this one. See, the same arc length. From point C, you cut this. Okay, you cut at the point CA. So you join them. This will get exactly parallel. Okay, join them. Call this one C prime. So you can see now that A, B prime, C prime is the required triangle, which is 2/3 of this original triangle. Okay, so like we did before, if you want to prove that these two lines are parallel, you just take your protractor and see and check the angles, how much it is. This is 95. Okay, check again from here. This is also 95. So similarly, you can check for angles here. They'll be exactly the same. So therefore, A, B prime, C prime is the required triangle, which is 2/3 times of this isosceles triangle, of the isosceles triangle A, B, C. So this is the required construction. Now we'll do the next exercise, 11C, question number 1. We have to draw a circle of radius 4 cm and draw two tangents to the circle inclined at an angle of 60 degrees to each other. Okay. First thing, before we do this construction, I want to remind you about circles. Okay. When there is a point inside the circle, suppose this is a point inside the circle, this point, from this point, we cannot draw any tangent. Okay. Second thing, when this point is on the circle, we can draw exactly one tangent to this circle. Okay. Fine. And number 3, when you have a point outside the circle, if you want to draw a tangent from this point, you can draw two tangents from this external point. Okay, these are the three points you have to remember. Also, the fourth point is that when you have a circle, if suppose I draw a tangent at this point, okay, this is just a tangent to the circle, the radius of this circle with this tangent will always make 90 degrees to the tangent. This radius of the circle will make 90 degrees with the tangent to this circle. Okay, so this here we have to draw. Let me draw a rough sketch of this one here. Okay, we have to draw, suppose this is a circle of radius 4. Okay, of radius 4, we have to draw those two tangents which are inclined at an angle 60 degrees to each other. Suppose I draw a tangent from this point outside of it. Okay, these two tangents will make 60 degrees to one another. Fine. Okay, we all know that this is also a radius. It will make 90 degrees with this tangent. This is also a radius, will make 90 degrees with this tangent. Okay, before constructing this one, this, I'll just give the name. C. This is A, this is B, this is C, this is D. This A, B, C, D, it is a quadrilateral because we have 4 sides. And we all know that the angles in a quadrilateral, if you sum all those angles, it will make 360 degrees. So therefore, this is already 90, this is already 90, and this one we have to construct these two tangents at 60 degrees to each other. So now find how much this angle will be. Okay, just add all these angles. See, I'll just take this one as x, so this is 90, this is 60, this is 90, and this is x. Okay, plus x. If you sum all these, you will give 360 degree. Okay, so you add all these, you will get 240 plus x equal to 360. Find x, 360 minus 240, you will get 120. So therefore this angle x will be 120 degree. Okay, so now let us construct here. First of all, we will draw first a circle of radius 4 centimeter. Okay. Just first of all, in your rough side, just draw 4 centimeter. Okay, this is your 4 centimeter. Again, with your compass, just measure this 4 centimeter that I've drawn here. Okay, this is 4 centimeter. Now you draw the circle of this radius. Okay, this is the circle of radius 4 centimeter. So next, what will you do? You just take any point A, okay, any point A on this circumference of the circle. You see this dot here is the center, okay. Let me draw this side, okay, fine. So you join OA. Okay, let me draw A a bit this side. Okay, this one, take this one. So join this one, OA. Okay. Then, next step, what you will do is, because this angle here is 120 degree, I have calculated here in the rough side. So draw 120 degree, AOB, AOC, you can take, you draw 120 degree. How do you draw 120 degree? From A, okay, from A, take any arc, okay, from this point O, we need to draw 120 degree. So just take, okay, take an arc. You see this point of intersection of this arc with OA, you take the compass there with the same arc, you cut in this arc, okay. You see this intersection again, you take the compass and then you cut this side, okay. Join this, you will get 120 degree. Join them, you will get 120 degree. So this is your 120 degree. Call this one C as I have drawn here. Okay, next step is, we know that this is the radius, and the radius with the tangent, it makes 90 degree. So at A you draw 90 degree. Okay, at A you draw 90 degree. Draw an arc first, and then you see this intersection, you put this compass there, you draw this arc. Again, take this arc or this intersection of this arc with this cut here that I've made, you cut on this first arc and above. Okay, take again from this arc, you cut on this one, the new one. So if you join A with this intersection, you will get 90 degree, a line which is 90 degree to AO. Okay, join them. Join this one. Just extend it. Okay. So this is 90 degree. Okay. Same thing for C, because OC is the radius. At point C, you draw 90 degree. Okay. Just take this compass, you cut this side, okay. Then you see this intersection again. You take this compass there. First you measure correctly the arc. From this here you cut. Again from here you cut this side and this side. Then you cut this. Okay. Join C with this point, you will get 90 degree. Okay, so call this one B. So you see this BA and BC, they are tangents to this circle, and they make 90 degree with the radius. This BA is a tangent making 90 degree with the radius OA. Similarly, BC is 90 make an angle 90 degree with CO. Okay, so this is your 60 degree by constructing from here. So you can check whether it's 60 or not. You can just check from your data. So you will get 60 degree. Okay. So therefore you can just write here AO and OC are radius. Then AB and BC are the tangents. And then angle ABC is equal to 60 degree. This is the required construction. Okay. Now we'll move on to question number 3 from the same exercise 11C. The question is, we have to draw two tangents to a circle of radius 3.5 from a point P at a distance of 6.2 cm from its center. First of all, we will draw a circle of radius 3.5. So as before, just mark on the rough side 3.5 cm. Okay. 3.5. Then with your compass you measure 3.5. Okay. Now you draw a circle of radius 3.5. So you mark the center as O. Okay. So next step what you will do is, from the center O, you draw 6.2 cm to the point P. Okay, mark 6.2 cm from the center. Okay, this is 6.2. You mark this one P. Okay, so this one is 6.2 cm, and as you know, this is the radius 3.5 cm. Okay, so next step we have to draw these tangents. So first thing what we will do is, we'll draw first the perpendicular bisector to this line OP. Again, with your compass you take a much bigger arc. Okay, from point O you cut above and below. Again, same arc, from point P you cut above and below. So if you join these two points, this intersection, you will get the perpendicular bisector of OP. Okay, join them. So this point, the intersection of this point, this will be the midpoint. Call that Q. Okay, call this one Q. So Q is the midpoint of PO. So next what you will do is, with O as center, you draw a circle of radius, with Q as center. Here with Q as center, you draw the circle of radius QO or QP, which is the same. So you draw a circle. Okay, so you get the second circle of radius QO with center Q. So next, you see this second circle, it intersect at this point with the first circle and at this point with the first circle. So you join P with these intersection. Join them. Okay. From below also you join. Okay. So you call this one T, this one T prime. So now you have got the required tangents PT and PT prime to this circle of radius 3.5. So you write here PT and PT prime are the required tangents to the circle of radius 3.5 centimeter from this point P. So this is the required construction to this question. So we have come to the end of this chapter, and I really hope that you have understood whatever I have explained to you. And until then, please take care and stay safe. Thank you so much.